Hello guys, welcome back to today's class where we're looking at the Pascal's triangle. We already looked at how we can actually derive the Pascal triangle. In today's lecture we'll be looking at solving examples using the Pascal's triangle. So we have an example here that tells us we have here using Pascal's triangle, expand the following. Remember figure 1, we have x plus 3 all raised to the power 3. We all know we can actually expand this using our basic expansion, but we won't be needing that now. All we need to do is to use our Pascal triangle. And then from here, since we know what is a Pascal triangle, from our Pascal triangle, we need to bring out the coefficients for power theorem. From Pascal's triangle, for power theorem, we know the coefficients that we use for power theorem, they are arranged in the order 1, 3, 3, 1. So you can easily check back on your Pascal triangle, so you can see what you need to see from our Pascal triangle. You know we have 1, 3, 3, 1 for our power theory. So that is this here. So you just bring it out and then use it as your values of your binomial coefficient. Coming back to this, we have x plus 3 all raised to power 3. We know these are our coefficients. We can easily now use them. Now, how do we now use them? Even now that we have gotten our coefficient. Now, before we even apply our coefficients, we need to know how we expand this. Now, we have a general power, a total power of 3, and then we have two values. We have x and we also have 3 here, all raised to a power of 3 when they are summed up. Now, the first thing we do, the first value here takes all the power, while the second value takes no power at all. What do I mean? I mean, x here takes a power of 3 times 3, while 3 takes a power of 0. So what happens is that the first value takes the total power, the second value takes no power at all, and then they keep on summing it till the first value takes no power at all, and then the second value now takes all the power. How does that happen? From 3, 0, it becomes x loses one of its power, that is from x raised to power 3, it becomes x raised to power 2, then 3 now becomes 3 raised to power 1. So the one that has left this 3 has come to this. So it kind of like is actually like shedding its power to the other value. So from 3, 0 it has become 2, 1. Going on, from here we have from 2, 1, this x again loses one of its power to 3 again. Then you have x raised to power 1, then we have 3 raised to power 2. Still going on, x loses its last remaining power, then it becomes x raised to power 0, 3 now becomes 3 raised to power 3. So this is the very first thing we do. We bring this out in a sequence where the first value takes all the power, the second value takes no power at all. Then furthermore, the first value begins to lose its power. As it's losing its power by 1, the other value is gaining that power. So 3, 0 becomes 2, 1. 2, 1 becomes a power of 1, 2. 1, 2 becomes 0, 3. So it's kind of a trend where the x power is reducing while the 3 power is increasing by 1. So after we are done with this, the next thing to do is to slot in our binomial coefficients in order. That means the very first one we have here is 1. We have 1 times this. The next one we have is 3. 3 times this. The next one is 3 again. 3 times this, and then 1 again. Now that we have done all this, all we need to do now is just simplify and expand. Now, from here we know this is 1. This is basically 1. This is basically 1 times x raised to power 3 times, we know 3 raised to power 0 here is 1, plus 3 times x squared times 3, plus we have 3 times x raised to power 1 remains x, 3 raised to power 2 is 9. We have 1 times x raised to power 0. Remember that any value raised to power 0 is 1, aside from 0 itself. We know 3 raised to power 3 here is 27. Moving on, we know this will give us a value of x cubed plus 9x squared plus 27x plus 27. Now we can see that we have been able to successfully expand this particular expression using our idea of Pascal's triangle. So in the next class, we'll be looking at this theorem figure 2, where we actually use the same principle to expand. See you next class.